Hello. So I'm over here. Hi. So I'm going to be off camera on this one. That way I can help show you some examples of the characteristics of minerals that I'm talking about, which is going to help us identify each different type of minerals. We got to look at these different characteristics to help figure out what kind of minerals we got. So the first characteristic that you'll typically look at when you're trying to find, trying to identify a mineral is luster. Luster is defined as how light is reflected from the surface of a mineral. So how does the light bounce off of it? There's two broad categories that I want you to focus on, either metallic or non-metallic. So let me show you my examples here. Move this out of the way a little bit. So these two minerals have a very metallic luster to them. They're very shiny, they shine like metal. They're very shiny, shine like metal. It's a metallic luster. Versus things that have a non-metallic luster. Now this looks shiny, but it's more shiny like glass. Same with this thing. This looks shiny, but it's more shiny like glasses. Same with this. These are non-metallic luster because it doesn't look like shiny metal. It's not shiny or not, it's shiny metal or not. And while these are shiny, they are not metallic. Another good example here is something like this. This is, not only is it not metallic, it's not shiny at all. So that would be a non-metallic luster. All right, so that's one characteristic. The first thing you want to look at is luster. Next thing is something called cleavage. Cleavage is how a mineral breaks or cleaves. So cleavage, again, the ability for a mineral to break along preferred lines. Here's some examples of different minerals that have good cleavage. There is one direction of cleavage, meaning it only breaks into one flat plane, thin sheets. Two directions of cleavage, two sides are parallel to one another. Three directions of cleavage, three sides are parallel to one another. So you're looking for parallel sides. For instance, let me go to this one. All right. So this this mineral has good cleavage. If I were to smack this with a hammer, all the small pieces of this thing would look just like this. Will have the same shape because cleavage is part of a mineral's characteristics. These sides are parallel to one another. These sides are parallel to one another. And these sides are parallel to one another. This has very good cleavage in three directions. Here's another one with good cleavage. If I were to break this mineral, you would kind of form these different cubes. This has good cleavage. This is one direction of cleavage. If I were to break this into thin sheets here, so it cleaves, how it breaks, see it breaks into these nice thin sheets. It's kind of stuck together, but it breaks into these nice thin sheets, of which on those sides of the sheets, either side is parallel to one another. You can see it broke into these little things that have little sheets. So anyway, cleavage is how it breaks. However, there are some minerals that do not have cleavage. For example, if you were to smack this with a hammer, there's no parallel sides to it. There's no cleavage to it. It doesn't break nice and neat. It just, in essence, fractures. Cleavage is a tricky thing because it's how a mineral breaks, not how a mineral grows. For instance, here's the mineral quartz. It does have some nice flat sides to it, but these are not cleavage faces. This is how the mineral grows. How it breaks is right here. This is how it breaks, and there's no pattern to its brokenness. It just kind of fractured. So quartz, while it grows nice and flat sides, you got to be careful because how it breaks is like this. It just kind of fractures. It does not have cleavage. It does not break into nice, neat, flat planes. And here's some more examples of cleavage. Here, one of my favorites is this octahedral 4 sides of cleavage. Something like this. It's kind of cool. If you were to smack this with a hammer, it would make smaller portions or smaller examples of that. Very interesting mineral. Very interesting. All right. Again, if it doesn't have cleavage, then it just kind of fractures. So fracture is when a mineral breaks with seemingly no planar pattern. There's no rhyme, no reason to it. Again, here's another example of something that just fractures, no cleavage. No cleavage. Another characteristic we can look at besides lusters, typically we look at first. Cleavage, it's hard to understand for the introductory geology student. Once you can understand it a little bit, it does make identifying minerals easier, but again, it can be hard for the introductory student. However, something that most introductory students can begin to understand is hardness. All right, hardness is a mineral's ability to resist scratching. There's a scale called the Mohs hardness scale, and that scale goes from 1 to 10, and it uses these kind of example minerals to make the scale. For instance, 1 is the lowest on the Mohs hardness scale, the softest 1, and that's the mineral talc. The hardest mineral is out of 10 is a diamond. Diamond is the hardest mineral that we know of. That doesn't make it strong. If you were to take a diamond and smack it with a hammer, it would just crumble. Hardness isn't how strong the material is. Again, it's the mineral's ability to resist scratching. Therefore, nothing can scratch a diamond. I take that back. The only thing that can scratch a diamond is another diamond. That's it. We also can use a few different common things to help us figure out the hardness of a mineral. Fingernail has a hardness of about 2.5. A copper coin, like a penny, about 3.5. A knife or glass even has a hardness of about 5.5. Steel has a hardness of around 6.5. So we can use these different things and try and scratch or take these minerals and scratch these objects to see if it scratches. So, for example, what we do a lot of times is use what's called a glass streak plate. This is just glass. So, what you can do is take a mineral, all right? You can take a mineral and you just scrape it along the glass streak plate. I'll kind of just use this top corner here. Nothing. Did not scratch it whatsoever. All right? You can't even hear anything. However, if you have a mineral and it's harder than glass, then it should scratch it. So let me try this again. Ready? Can you hear that? You can even hear it. Let me see. Oh yeah, you can kind of see it. See those two little scratches right there? So this mineral is harder than glass, so this mineral scratched it. And glass has a hardness of around 5.5 on the Mohs hardness scale, so whatever this mineral is has a hardness probably 6 or above. Whereas this mineral did not scratch the glass, so it probably has a hardness of 5 or below. In fact, this has a hardness of 4, this is fluoride, and this has a hardness of 7, this is quartz. So another way to help identify minerals is just scratch them on glass. Does it scratch glass? Yes or no. If it does, it's 6 or harder. If it does not, it's probably 5 or less on the Mohs hardness scale. So that's kind of how that works. Another one is called streak. Streak is the color of powder left on a streak plate when the mineral is scraped across it. So in this case, we're not trying to cut into the streak plate, but what we are trying to do is just rub some of it off in a powdered form to see what color we get. So streak is kind of unique to minerals as well. So for example, if I take this mineral and I kind of color, scratch it, you kind of see this mineral gives me a kind of brownish, reddish streak. That's characteristic of this mineral. Here's something that's also kind of a brownish red. Let's see what color I get here. Nothing. Well, maybe it's just too light. Let's try. Oh, its streak is actually white. That's interesting. So, just because the mineral is a certain color doesn't mean its streak will be that matching color. This mineral is kind of like a aquamarine color. So let's see. Whether I use the white or black streak plates, they're both made of porcelain. It's just what will kind of pop up. So let's see. Nothing. Let me try this one here. Oh yeah, even like a little brighter white. This one actually looks more of a gray streak. This one is more of a white streak. Okay, so this kind of pinkish, brownish mineral gives a gray streak. This green mineral gives a white streak. So streak is kind of very interesting. It's very, again, telling of what mineral characteristic is. So that's another characteristic we can look at to help to identify minerals. We can look at all of these things. Color. Color is a tricky one. Color is probably one of the last things you should look at when trying to identify a mineral. For example, you know what, let me put a little white background there. Here. Let's try this. Let me blow this up. Hard to see here. Let me get a flashlight on here. Where's my phone? Here we go. Let me pump up the jam here a little bit. 1 second. If you can see that, but here we go. This mineral is purple, and this mineral is the green-blue. Guess what? Those two things are the exact same mineral. So color. Color is one of the last things you should look at. Another good example here. This one's clear. This one's blue. The same exact mineral. Color is one of the last things you should look at. Not that it's not important, but it really is one of the last things you should look at because it can trip you up every time. So again, all three of these minerals are the exact same thing. Sometimes minerals can have different colors within them. It's kind of weird, kind of freaky. All right, some minerals fluoresce under black light. That's that kind of black, that violet light that you would see in like a haunted house or up in the club. So some minerals under black light will glow. So for instance, this mineral looks kind of white grayish in daylight, but under black light it's green. This one kind of like a pinkish with black, but under black light it's orange and green. So kind of gray color, purple color here. So some minerals will fluoresce under black light. They glow under ultraviolet light. Some other characteristics. Birefringent. There's some minerals you put on top of writing and you'll get this kind of split double vision called birefringent when you look through it. So that's indicative of the characteristic of the mineral. Not all minerals do that. Some minerals are magnetic. Right? So some minerals, one way to easily identify them, a mineral or a magnet sticks to them. So some are magnetic. Some react with acid. So some you put a little bubble or a little drop of very weak hydrochloric acid on them and they will bubble and fizz. It's kind of hard to show you on the camera here, but if you look at this image, you put a little drop on it and it will react, the acid will react with the mineral and start to bubble, fizz, even make little bubbles. And then taste. Yes, taste. There are some minerals that are oh so delicious. For example, if you were to lick this one, yum, 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 yum. You could lick all the minerals you want. Really only a handful are tasty. But sometimes when you're trying to distinguish, for example, between these two minerals, which are different minerals, right? I'll show you. Let me blow this one up. These two minerals, they do have different characteristics, different cleavage, different hardnesses. But if you're really trying to figure out real quick the difference between these two, this one's tasty, this one is not. So taste can be part of how you identify minerals. All right. With that being said, looking at those characteristics, we'll use those in lab to try and at least virtually identify some different specimens of minerals. But we'll go ahead and pause there. When we come back, we'll now talk about the rock cycle and rocks. Again, minerals and rocks are two different things. We'll discuss that in just a minute. See you soon.